Assalamu alaikum. So today we will be seeing one more topic of our workshop, Internet of Things workshop, that is your sensors and actuators. So you might be hearing about sensors or you might be knowing about sensors, but this is a new term, actuators, and generally on a generally terms, sensors and actuator comes together. So here we will be discussing more on sensors, and then in the later on workshop lectures we will be discussing on actuators. So basically sensors are the devices that are giving inputs to your microcontroller, and you can say that for Internet of Things these are the starting point of the signal, and your actuators are the, you can say that output of your microcontroller will be displayed or will be outputted to somewhere, or will be transferred in a physical changes there. Those devices are called as actuators. So sensor basically senses or measures something, and then actuators actually displays something or informs you physically. So sensors generally senses in any other physical quantity and then convert it into an electrical signal, and that electrical signal is send it to your microcontroller, and from there the microcontroller send it to the actuators so that it can display to the end user. Now it can the actuators can be your LED screen, the actuators can be your switching devices. The actuator, like for an example, if you need to control the temperature of a room, and their room has an AC, air conditioned device, the thermal sensors or the temperature sensor will sense the temperature, and it will send it to the microcontroller. The microcontroller will compare with the thermal sensors, that set preset value, and then it will send the signal to the actuators, and here the actuator can be a knob or the parameter, or the knob that can or the switches that can switch on, or that can regulate the temperature of the AC. Okay, so actuator does not only mean like an LED screen, it can result in other controlling device also. Even your motors can be an actuators if it is getting controlled by some sensor and microcontroller things. Okay, so let's start our lecture. We'll be discussing here more on sensors. We will be discussing different types of sensors. We will be discussing on their, and on which name they are available in the market, and how they are performing their duties, and how they, what is the working principle, and what is the output we are actually getting. Okay, so our more focus will be on the working and what data is coming out from there. Then we'll be seeing the actuators. Okay, so let's start. First we will be starting on our first sensor, that is your temperature sensor. So in the market there are two types of sensors available with the name LM35. This is the basic sensor name that is available here. I will show you the figure also. And the next is DS18B20. So this is the another temperature sensors, and that are available. There are others temperature sensor is also available, but these are the common sense temperature sensors which are available for your projects, and we'll be discussing what are the features of these two. But overall, if we are considering a sensor, the minimum terminals of a sensors are, there is three terminals. Whatever the sensor will be, minimum terminals will be three, and maximum it can go for four also. But we will be discussing whatever sensors we will be seeing here, we will be giving our three terminals only. So your generally the first terminal is your VCC. Okay, this is the supply, and this pin is your supply. The middle pin is the signal pin, generally signal pin. Okay, so this is the signal pin, and the last pin is your ground. So we'll see it here. So if a sensor is there, these three pins will be always there: VCC pin, signal pin, and your ground pin. So this is your LM35. Here you can see the three pins are there. So the first pin is your VCC pin, and your middle pin is your signal pin, and the other pin is your um, this ground pin. So it might look like a transistor, you might even see, but here uh, this name for is LM35. This name suggests you that it is a temperature sensor. This name can differ. The upper part is the company name. Okay, so the upper part is the company name, but the middle part is LM35. This different companies produces different temperature LM35 of the same quality. Okay, so next is the DS18B20. So this is another sensors, and this sensor has again three pins. You can see here VDD, data pin, and your ground pin. But here you can identify the wires by the colors. So as you can see that the VDD, or the temperature voltage, input voltage is white, red, and ground is your black, and data pin is your white pin. Okay, so maximum point of view, if I maximum what you can say, on comparative scale, the all the sensors have these three pins. This generally has these three pins. So the the what is the difference between these two? So these sensors has generally has 5-volt input. Okay, 5-volt input, or 5-volt input as a maximum, and your 3-volt input, 3.3 volt as minimum. Okay, so your input voltage, that is your VCC, is changes from 3.3 volt to 5 volt. Both the sensor can operate on this range, and if we go on for hands-on, so we will be giving this voltage level in during our hands-on purpose also. So this is the minimum. The maximum limit can be of 60 volt. Okay, so maximum limit is can be of 60 volt. Now this LM35, it can measure from minus 55 degrees Celsius minus 55 degrees Celsius to 150 degrees Celsius. Okay, so from minus 155 degrees Celsius to 150 degrees Celsius it can measure. Now the problem is, the main purpose is what is the major difference between these two. The next question is, what is the data coming out, what is the so I have told you about these two pins. These two pin will be connected to your 3.3 volt, and this is to the ground part. Okay, so these are your two connection we have already done. Now this third pin will be going to the microcontroller. This third pin will be going to the microcontroller, and there are in the microcontroller, that is your either, or we will be generally using Arduino, and in case maybe we can go for your Raspberry Pi. In Arduino, there are analog pins and digital pins. So generally, this data pin is connected to your analog pins, because the data will be coming out is in analog. So we need to convert this data to digital. Okay, so we need to program it, and then we need to convert it. But the case is different for this DS18B20. So here the data will be in either in your digital data. So we need to connect it into your digital pin, and this data will be from 9 bit to 12 bit. So that is the major difference between these two. The data will be from 9 bit to 12 bit, okay, from the this data pin. So you can expect your so you need not to program it. You need not to go for your analog to digital converter. If you ask me, sir, what is an analog to digital converter here, so what we will be doing, we will be making a program such that this analog data can be converted to digital. So here the data is already coming in digital, okay. So here the data is already coming in digital. Now next is the working principle. So let's start our working principle. Overall I have shown you the temperature range and what is the, now the as per the electrical side, if we are thinking what is the electrical point of view, generally these sensors does not take much current, okay. So this the general drain current, you can say the current drain by this LM35 is 60 microampere. It's very minimum as per requirement of your, as per electrical point of view. If you say this is a very minimum current that is flowing in your sensors, okay. So this but it can go for it can go in your milliamps, okay, but it will never go above 1 milliamp, you can say that. So it will never go above 1 milliamp because it will leads to your destruction of your this temperature sensor. So here more effect will be on if you are saying the current value, this is the maximum range of the current. So now naturally if you see that if you are giving a voltage of 3.3 to 5 volt, obviously the data pin that is sending your data will also have a voltage less than 3.3 or 5 volt, okay. So that voltage the data will give you the because the input is always input, you are giving 3.3. If you are giving 3.3, obviously the output will be less than that. There is no such device that can magnify that voltage, okay. So the data will be always coming below that range. So let's see what is the, how it is operating. So here you can see this is the inbuilt structure of your this. So generally your temperature sensor are used by using are made up of with a semiconductor devices, okay. So there is a thermistor, there can be your transistors that has your that changes its resistance with your temperature coefficients, and so the resistance changes, and then accordingly to the current flowing from there, that can develop a voltage, and that voltage can be measured here. So here this LM35 has a different structure here. So there. So here you can see there are two transistors, and these two transistors have different size of your emitter. So different size of your emitter means the area of emitter on these two has difference, has is 10 times. Okay, so that means the emitter current will be 10 times larger. So Q1 will have a 10 times larger emitter current compared to your this Q2. Now as you can see here, the input to this Q1 will be quite large compared to the Q2. So these two transistors will have different level of current from this point or this node. Okay, so that will create some amount of current will be coming from this. Okay, so there will be a voltage difference, and that will cause there will be a voltage difference, voltage develop across your R1. So why this voltage, or why this voltage is developing? Because these two devices are quite these two devices have, if get affected by temperature. Okay, once the temperature will be changes, so this either of one of the devices will be your absolute temperature, and the other will be your the relative. You can say that with this respect to them, it will change the amount of current required. Now that's why the two has a 10 times different this area, the 10 times different the current level. So the 10 times difference will make you different, the amount of current will be flowing differently in these two this transistor depending on the temperature. Okay, so that makes the voltage different, and that voltage can be measured. So once the temperature varies, there will be a voltage difference, and that can be measured. Now what happens here, you are converting your temperature signal into your voltage signal, and that voltage signal can be measured here. Now here if you can see here, this is your 10 millivolt per degree Celsius. For so if there is a 1 degrees change, there will be a difference of 10 millivolt. So 1 degree Celsius, there will be a difference of 10 millivolt, and that 10 millivolt can be measured, that will be sent through your data pin. So this data pin, if if it is having a voltage, suppose at 25 degrees Celsius, the set value, or 25 degrees Celsius, it has suppose 3 volt, or suppose 3.5 volt. Okay, so 3.5 volt. So if there is a change of 20, if there is a change of 1 degree Celsius, suppose 26 volt, if 26 Celsius it's happens, so what it will show, that 3.5 volt plus there will be a 10 millivolt change. Okay, so that this change will be shown in your will this amount of voltage will be developed in your data pin. This amount of voltage will be developed in your data pin, and that data pin will send it signal to your microcontroller, and there that microcontroller will sense it, and then it will you need to convert this data. This is the amount of voltage that is coming in, and now you have to convert this is an analog data. Now you have to convert, you have to do some this programming part, and there you have to convert this millivolt to degree Celsius, so that it can be to your meaningful sense. Okay, so this is how your LM35 works. Okay, so same way here, this also works in the same way, but it has an inbuilt, you can say that inbuilt data. It transfer you directly the data. You need to make a control A to DC converter, but this has a difference, is that this is generally used in measuring the temperature of a fluid, like you want to measure the temperature of a transformer oil. Okay, so you will use this type of temperature sensor, DS18B20. Okay, so this will not work in your fluid things. Okay, so this is more complex. Suppose you want to measure the voltage of the soil, or sorry, want to measure the temperature of the soil. So you need to use DS18B20. So this is what the difference is in these two things. So we'll be discussing next also the upcoming. Generally, if you go to the airports, they use infrared sensors. So we'll be discussing in the next slide. So this infrared temperature sensor, you might have seen it in most of the places, like the airports, or in your big offices where they want to note your temperature. They are pointing a gun shaped device onto your head or into your hand, and then they will check the temperature. So that is one of your infrared temperature. But if you see the internal construction or internal shape of the sensors, it looks like this. It has a four terminal. I have already told you in the previous thing that it might be having four pins or three pins. Okay, so here this is your four pins, and that four pins can be four terminals. That is, two terminals is quite fixed, that it will be having a VCC and your ground, and there is an SDA and LDA pins that have a difference. That data pin is here. The two different pins will be there. We will be discussing it in another when we do the hardware part. There will be discussing more clearly, or we will see the Bluetooth device. Then we'll be seeing those pins. Now here, if you check out the name sequence, it's quite long here. GY906 MLX. So this is the common number, or this is the common availability, and this is the company name. Okay, so the company name can be deferred, but this is the number, or this is the name of your infrared sensors that are available in the market. Okay, now how what is the working? So this sensor, as you can see, that this is a round shaped sensor, and it points out, it gives out the rays of your red light rays you can expect. So it's work on the principle of black body radiation. So what is actually a black body radiation means? So if there is a body, any body, so if there is an, excuse me, if there is an body, and if it has a temperature above 0 degrees Celsius, if the temperature is above 0 degrees Celsius, anybody, it says, so if the temperature is above 0 degrees Celsius, the molecules of that body will be will move faster. Okay, and that molecules will emit infrared radiations during their movement. Now, this sensors, what it does, it has a focus and it has a lens, and it has an equipment that can this absorbs this it can absorb those infrared radiation from those molecules, and then it convert those signals to electrical signal, and that equipments are that is called as thermopile. So thermopile is an device that converts, or that converts this infrared signal into electricity. So this is your incoming infrared signal, and there is a two part, that's an hot junction and the cold junction, and the difference between those two produces a electrical signal. So it acts as a transducer. So it acts as a transducer. So a transducer is a device that takes and that converts any energy into electrical energy, electrical signals, you can say that. So this is the thermopile. What happens, it's absorb energy, and then it changes. So whatever the number of radiations, the number of as I have told you, the number of radiations or the number of absorption increases with respect to the movement of the molecule. The molecule moves faster, it will emit more radiation. Now if there is a hot body, obviously the molecule movement in a hot body will be more compared to a cold body. So the more the movement, the more radiation will take place, and the more absorption by this the focusing lens will be there. It will absorb more radiation, and then that will develop more voltage. Now this voltage will be converted into signal, as I have told you previously. How the so the working voltage will be again on the same type of 3.3 volt to 5 volt. Okay, so it does not changes more. So that signal will come out, and then we have to readjust. This is most. So next is your humidity sensor. Now basically this humidity sensor can measure your temperature as well. uh, so it is thus can be named as HT. Here in the name series, if you see, there are two humidity sensor name here I have suggested. This is your DHT11 and DHT12. So these two are available in your market. So H is for your humidity and T is for your this temperature. So D representative Dallas. There is a place. There is a company. There is a place in your America, Dallas. So there you have a company that produces that has developed this technology. So the DHT is named from there. Okay, so what is the basic difference between these two? That DHT11 and DHT12, there is a just a pin difference, and there is a what you can say that the quality will be resolution, and the data transfer will be quite different. Now here, this is a module of your DHT11. Here you can see here three pins are there. Now these three pins, obviously I have told you that middle will be your data pin, and these the other two will be your, this is your VCC, and this is your ground. Okay, and this is your data pin. So this is the common configuration that is going on for all the sensor. Now DHT12 has four pins. Okay, so this DHT12, this end pins is your VCC, and these two, this one is your ground pin, this one is your ground pin, and this is your SDA pin, SDA, SDA, and your this the next last one is your SCL, SCL. I'll explain both the pins. What are these two pins? Now here in DHT11, the single data pin, that is your middle pin, generally this is a module. Okay, so there is a difference between a module and a sensor. So a sensor will always have four terminals, but a module can have three terminals. Okay, so if you search for DHT11 sensor, it will have four terminals. Okay, and if you search for DHT11 sensor, it will have a sensor module, it will have three terminals. So this is a sensor module. Now this data pin will carry both your humidity as well as temperature data, but there will this data will act, it has to take both this the both the message, humidity as well as temperature. So there will be a time difference between these two transfer of data. Okay, so this again works on the same voltage level, 3.3 to 5 volt, or 5 volt. Here the operating current will be a bit more, that is 0.3 milliampere, but it does not went to ampere level. So mind you that even if you take any sensor, it will work on your milliamperes level. Okay, next is your temperature difference. So this temperature, as it is, it has it majorly focus on your humidity. So it is, the temperature ranges from 0 to 50 degrees Celsius. Okay, so temperature ranges from 0 to 50 degrees Celsius, and your it measures the humidity uh, from your 20% to 90%. So the major focus is for the measurement of humidity. It won't focus more on temperature parts. Okay, so this is an additional advantage, but like if we can't use if we are measuring the temperature on our this output for your weather conditions or anything, on that basis it's preferred. But if you are measuring the temperature of something very harsh like liquid, or you can go for your any high temperature above this range, so better preferred that this temperature sensor DS18 B20. Okay, so don't think like your humidity sensor will give both the things. Okay, both the temperature as well as, so there is a problem of transfer of data also. So microcontroller sometimes overlap these data, and it will it does not have, because the same pin transfer both the data, so there is a problem with that also. Okay, so now the next this is a DHT12. Here you can see here these two pins are the new pins, SDA and SCL. Okay, so these two pins are like serial data pin. This is your serial data pin, and this is your serial clock pin. Serial data pin. Okay, and this is your serial clock pin. So actually what happens that we are using this these two pins for using your, if we have two different uh, things, output things, like your LCD screens are there, LCD OLED screens are there, and that is attached to your this microcontroller, and this humidity sensor DHT12 is also attached to your microcontroller. So what it will send the data, and the data will be displayed in your OLED screens. Now what happens, the OLED screens works with a different clock frequency, and your this DHT12 will work for a different clock frequency. So to equate both the clock frequency, we have an extra what you can say, extra pin. So that pins holds the holds the clock signals, adjust that clock signal, or note the clock signal accordingly, so that there will be no delay of data, or there will be no intermingling or overlapping of data. So that is why there is a four different pins. So, and that has an extra pin, that is a clock pin. So that is the same four terminals can be your in your infrared temperature sensors also. Okay, so I hope this is quite clear. You will get more clarity once we will get into the this hardware part. You will get more things to note. Okay, so so in your humidity sensor, there is one more thing, that this the working principle. If you look around, it works on the principle of your capacitance, the voltage across your capacitance. Now there is a capacitor, and what happens, this capacitor has some dielectric material, that, and this dielectric material will be such dielectric material that changes its capacitance with respect to the moistures. Okay, so if there is a more moisture availability is there, So the capacitance will changes the current flowing capacity between them. Like here, if there is a more moisture content in the air, so this dielectric medium will become more will have more electrons that can conduct your capacitor current, okay, from your positive plate to your negative plate. Now, so what happens, the flow of electron will be more, and the flow of electron IC will be more, and that will generate more capacitive voltage here, and that capacitive voltage can be measured or can be sensed, can be measured, and that will be sent it to the this microcontroller, that through the data pin. Okay, so and as you can see here, this is one of your capacitive sensor. Now the say in one area, so I have already in the starting part I have told you that the electrical parameters like your resistance, inductance and capacitance, these are the parameters generally used for developing voltage once the current flows through it. So the sensors is quite similar to that. Okay, so they use those technologies, they use those properties of the material, and then they convert it to the electrical signals. This is how your humidity is measured. Okay, now next is your current sensor. So we have, as per your electrical engineering is concerned, this is a quite important quantity or parameter which we require in most of our equipments. So this current sensor is generally available in the market with the name of ACS712. Okay, so this is available in the market, and here we need not to convert any other quantities into your into your electrical quantities. It's already an electrical quantity, but we can't measure this current directly, as there are, if there is a huge current flowing in a circuit, like in an electronic circuit, uh, for an electronic circuit I can say, for an electronic circuit 5 ampere is quite large current. As you have seen here, these devices operates the maximum capacity of these devices, it is in milliampere. So those electronics equipments, if they have 1 ampere, it's a very huge quantity for them. So what we do, that we need, if we want to measure a 5 ampere current, we need to use current sensors to as you can say that you will say that we need to step down the value from 5 ampere to that to 1 milliampere or that ampere level. Okay, so that is like if you see in your digital part, those digital, or that is your OLED screen, those works in your milliampere. So for that we need to convert your measured quantity, that what you are measuring, we need to convert it into that part. So this is your this is the current sensor generally available in the market. And if you have developed any project, final year project, on your electrical background, you will find this equipment. This is the common equipment which most of your electrical projects possesses, but you might not have seen it. Okay, so if you don't have seen it, you must see it. This is the thing that they put in your project. Now what is the working principle? So it works on the principle of Hall effects. Okay, so it works on the principle of Hall effect. We will discuss it all, but we must see which type of current it will measure. So it will measure both your AC as well as DC current. It can measure both your AC and DC current. And what is the magnitude? So this is your input. So whatever you want to whatever you which circuit you want to measure the current, like here is the motor. So, and this is your motor terminals, and this is connected to a supply. This is a motor and this is connected to the supply. So what you do, you put the one part here and the other part to the supply. This is how the connection is done. So this is the supply. Okay, so here this is the AC motor is, now the current will come here, it will flow from this side and it will go this side. Okay, so the current, now this current may be of 5 ampere or more. So the range output current for measuring the output current is from your 5 ampere or 20 ampere and 30 ampere. Okay, so till 30 ampere it can measure, till 30 ampere it can measure. So next is your sensitivity developed. Now what happens that it has a different sensitivity for different, for 5 ampere if it is flowing outside, it will develop 185 millivolt per ampere, 185 millivolt. Okay, so the data pin will change with this is called sensitivity. So if there is you can say that if 5 ampere is flowing, some output voltage is 1 volt or 1 millivolt, so you have to add 185 for 6 ampere. Okay, so this is the minimum range. Now if you change the current level, if you change the current level to your 20 ampere suppose, so if you have output current of 20 ampere, the sensitivity goes down. Okay, the sensitivity goes down to 100 millivolt per ampere. Okay, so the sensitivity, if it is goes down, so then there will be an accuracy level question mark with the accuracy. So for high current, this will be not preferred. For measuring your current sensor is not preferred for high current, so you need to go for your CTPT, you need to other. So this is your basically focused on your smaller current less than 5 ampere. Okay, so we don't also go for that 5 ampere level, we generally prefer up to 2 ampere. Generally this circuit is goes works well. Okay, and if you go to 30 ampere also, then the sensitivity also goes down. So now so what is the working principle of it? Now here again, this is the ground and this is the ground, this is the VCC and this is the data pin. Okay, so this is the common configuration goes on. Now the input voltage will be, VCC will be 5 volt. Okay, so VCC will be 5 volt. And what we need to know one more thing is that this VCC, if it is in 5 volt, this data pin will never be at 5 volt. Okay, so we need to put some resistance so that we can have a difference between these two. So this is called as pull-up resistor. Pull-up resistors, we will be using this thing. So pull-up resistor generally distinguishes between your voltage level of your this VCC and your this uh, data pin. Okay, now next, this is the function. Now what happens here, as you can see here, this is the magnetic core and this is the current flowing here. Now this is the 5 ampere and this is the what the current is going on. Now this magnetic core will have a constant magnetic force. Okay, will not change, will not suppose it does not change the magnetic force. Once the current flows, it will affect the magnetic effect or magnetic field from that magnetic core, and that if effect or that change will be noted and that will be amplified. Okay, and that will be amplified with some technique. This is your amplifier that will be amplified, and then it can be this is the data pin. Okay, so that is we are giving energy for this amplifier, input voltage for this amplifier. Okay, so this theory is called as Hall effect sensor. So Hall effect sensor is what the change in your magnetic field due to the flow of current, and that change can is reflected in the form of millivolt per ampere. Okay, that is the sensitivity part. So this is one of the this is the through your Hall effect sensor we can measure your current sensors. Okay. So next is the voltage sensor, and this is available with the name B25 REES52. This is your module. So whatever I have discussed, all most of the things are of your voltage sensor, current sensor modules I have discussed, and this is my availability in the market. So again, this is one of another electrical quantity, so we need not to change it from your electrical quantity to another form. So just we have to change your levels. So this voltage sensor looks like somewhat like this, and as it's quite similar to your current sensor, but the difference is that it possesses some holes type thing here. If you look around, this golden type holes are there. So this is one of your way to identify this. Now here the symbol is quite different. So the end terminals is your signal, and this is your plus is your voltage, and this is the negative is your, again you can put it from 3.3 to 5 volt. Okay, the signal can be measured now. Now this is your input signal, and now so 25 volt is the this VCC volt. This is the VCT terminal, and this is the ground terminal. So you can measure up to 25 volts. So the voltage must be equal to 20, not more than 25 volt. Okay, so 25 volt is also a quite large voltage compared if you are dealing in your electronics part. Okay, so this is the level. Now next is your how we can measure it. So this is measured with by using these two favorite equations of electrical engineering. So this is nothing but your voltage division rule. Okay, so voltage division rule, so whatever your input voltage will be here, and that you can change it into your low voltage output voltage for the measurement. Now the measurement value can be, you can use here capacitance and can use your resistance also. So if you are using a capacitance for voltage division, it will be your capacitor voltage sensor. If you are voltage sensor, if you are using a resistance, it will be a resistive voltage sensor. So it has a basic thing is it works on voltage division rule. Okay, so here if you check around, this is this type of things. If you see here, this is a resistance. Okay, so this is this module contains resistance. So this is a resistive type. So overall, if you look around your voltage sensor and current sensor is having a bit more complex principle to measure it rather than a voltage sensor, because even though current flows in a circuit, and that makes a difference. Okay, so if as per electrical engineering is concerned, it's a bit complex to measure a current. Okay, and a bit easier to measure a voltage. Okay, now that's why if you have seen the CRO and a CRO probe, and there if you have seen the measurement, most of the almost I think 90% 90% signals are in voltage. Okay, so you have seen a voltage signal in the CRO. Okay, you have not seen your current signal, because voltage signal is quite easy to You just need to step down the voltage to the electronics part on the CRO level. Okay. So till now we have discussed most of the sensors, and those sensors are somewhat related to your atmosphere and then current equipments. Okay, and then infrared sensors we have looked around. Now we will be going to one of the sensors that are more applied in your biomedical engineering or in your medical areas, medical lines, that is your pulse sensors. Okay, so this sensor is quite famous in those areas, in your medical areas, and this SEN11 57574 is the sensor's name. Now this is available, looks like this simple sensor, and it's has again three pins. So these three pins has your VCC, and then your ground and your data pin. Okay, so this works on a principle quite similar to your infrared sensors, but in your infrared sensors there is your black body radiation occurs, and it is assumed that the black body radiation sends your signal in your infrared, and that infrared is absorbed by the sensors, and then that is again converted through your thermopile and into your electrical signal. That is one way of measuring a day something in your body. Okay, in your body, if a human body is seeing, so just for an example I can say that if I want to measure your heartbeat, so that heartbeat can be measured by using infrared rays, like infrared rays, and that is your transmission. Okay, so transmission type pulse sensor. So in that transmission type pulse sensor we will use an infrared sensors, and that sensor will see the level blood levels in your body, and it will again wait, like your blood is pumped from your heart, and that pumped blood comes to your vein, and that vein will again bulge like this. If you see here, there will be a bulge. These two are your pumped bloods. Okay, so and in between it is lubbed. So lub and dubs are the two sound of your heartbeat. Now when it pumps your blood, the big large amount of blood flows through your artery, and here, and if it does not pump bloods, it is becomes normal. Now what happens if you use an infrared waves to detect this amount of this blood through infrared rays, this the molecules will be present here, and it will the molecules will be present here, and then it will eject infrared radiations, and those infrared radiation will be absorbed by your this sensor thermocouple. Okay, and that is one of the way of your, that is called as a transmission type sensor, pulse sensor. So it will note down the timing between these two, note down the timing. There will be a timer, and it will note down the timing between these two pulses, or these two uh, this instances, and then it will calculate the whole timing, and overall it will give you the pulse, you can say beat pulse. In the other way, if you can see here, there is a one more famous equipment, quite famous here, that's pulse oximeter. Okay, so pulse oximeter is also one of the famous measuring device, quite famous in your COVID times. I have explained in the previous video there that pulse oximeter measures the quantity of oxygen content on in your blood. Okay, so this pulse oximeter also, this oxygen level emits a particular wavelength, and that wavelength is absorbed by the infrared technology. And to note down the volume of the oxygen content in the blood, it will then predict, it can be converted into the microcontroller will convert it into the measured quantity, and it will reflect in your OLED. Okay, so and that is the one of the way of transmission type pulse sensor. Next is your reflection type pulse sensor. Here, this is your reflection type pulse sensor. What it does, it sends a green signal, and then it will sense the amount of green signal will be green LED. The amount of green LED will be noted. What is the amount of green LED is gone here, and then that is your, what is the amount of wavelength of your green light is going here, and then after it reflected from it gets reflected from the artery, what amount of green light is absorbed. Okay, so it will then it will keep on sending the green lights, and between these two bulbs, or between these two pulses, and it will note down the timer will detect the timings. Once it will note down the timings, and then it can again it will be converted into beats. Okay, so it keeps on sending the green lights, and it keeps on absorbing that photo diodes or photo detector will keeps on absorbing that lights. So between those two intervals, it will keep on noting, the timer will the counter, you can say that the counter will keep on counting, and then it will give you the final this value of your heartbeat. So I'll be more focused on your how the technology is working here, because that counterpart we will be discussing on your this Arduino. While programming Arduino, we'll be seeing that. So here in your transmission pulse sensor, we have used red color LED pulse sensor, but in here we are generally preferring green color. We can also use red color also, but this type of sensors works good in indoor works. Okay, it is precaution to it is very beneficial, or it will give good data when you work indoors. If you take it to the outdoors, the sunlight will affect your infrared radiation. The red light will be getting absorbed in the sunlight, and that will give you some negative results. So that's why in for outdoor application, they use green lights for measuring it. Okay, so this is the whole scenario of your sensors. I hope I have explained more number of sensors I have explained. And here, if you see, I have in the initial phase, I have seen that, told you that the all the sensors works on the one principle. This physical quantity will be there, and you need to convert it into an electrical signal, and then again you need to then you use those electrical signal in the data form, and that data can be converted into your meaningful things. Okay, so that is the whole sensor part. And this sensor basically how we can convert this signal, or this signal into a data part, by using either converting a current into a voltage form. Okay, or by using a transducer that can a physical movement can convert it into a voltage form. So overall, voltage is one of the important parameters in your electronic circuits that helps us to find out the this helps us to find in measuring the systems. Okay, so I hope most of the points are quite clear. If you have any doubt, you can contact me in my email id. Okay, so in the, I think most probably will in the next lecture we'll be discussing what we'll be doing with these datas. Okay, and then we'll be seeing how we can use the actuator parts. Okay, okay, thank you.